Now that we've seen call and apply, we can add one more piece, literally one more line of code that was missing from when we showed how to inherit from the event emitter to make sure that our pattern for inheriting in general is complete. And it's a pattern you'll see a lot when you look at Node.js code. All right, I just opened in my app.js file the greeter that we built previously. And you'll remember we pulled util and event emitter, added a property to greeter inside this function constructor, and the important line was util.inherits, which set up the prototype chain so that any objects I created with greeter would also find the prototype on event emitter down its prototype chain, giving all of my greeter objects access to all the methods and properties that all event emitters have access to, like on and emit. So that works great. But there's one scenario that we haven't covered, because inside the function constructor we can add properties and methods directly on to the object being created, as opposed to properties and methods on the prototype. The this keyword is the new object being created whenever I say new and then function constructor. So that's how I add properties and methods. But what if event emitter, or whatever else I'm inheriting from, also adds properties and methods directly to the new object, not necessarily the prototype? That is, a copy is made and put on every single object created, like we're doing here. Well, we're not including those on my new object, and that's a problem. It's an incomplete form of inheritance. So we can fix that up very easily with one line of code. Inside my function constructor, I'll say event emitter dot call this. Now what does that do? Well, event emitter is a function constructor, and so when it's invoked with the new keyword, the this variable points to an empty object and it adds on properties and methods. But I'm overwriting what the this keyword is, so I don't need to use the new keyword. All I need to do is say run the function constructor and pass the new object that has already been created. Then inside the event emitter function constructor, I'll have a bunch of properties and methods added if there are any to it. And because this is passed by reference, because it's an object, then I can just keep adding on my own properties and methods to that new object. This is equivalent to what some would call, in other programming languages, the super constructor, meaning the constructor that I'm inheriting from. But the basic idea is simply this in JavaScript. I'm using .call, I could also use .apply, in order to give it the new object that I'm working on so that it does its work of adding properties and methods to that new object, so that this keyword inside the event emitter will be the same this inside greeter. Add all of the properties and methods, add my properties and methods. And then the prototype chain is still set up the same way, so there are properties and methods available to all objects that are created from this function constructor. So this one line of code ensures that my object created from this function constructor has everything an object created from an event emitter would have. Just to make absolutely certain that we understand what's happening here, let's look at a slightly simpler example. I've gone ahead and made a new file here, app2.js, and in it I've put a function constructor that creates a person object. So it has two simple properties, first name and last name. And then on the prototype, we have a function called greet. And if I was to make then a new person, what would happen is there would be an empty object at first, which would be the this variable, and then that empty object would get these properties attached to it. And that would be it. But then I could call .greet because it would be on the prototype of that object, down the prototype chain. Now I want to make another function constructor. I called it policeman. And this object has its own special property called badge number. But I also want policeman to have everything that person has access to. So I used util.inherits and said policeman should inherit from person. And now I make a new policeman. And and call the greet function. What do you think is going to happen? Well, the greet function is available. But notice that first name and last name are undefined when I called the greet function. It said hello and then undefined, undefined. Why? Because util.inherits just connected the prototypes. It connected what's available to all objects being created from this function constructor. But the part here and here that actually attach properties and methods directly to the new object being created, the problem was this was never run, just this line here. So if I add person.call and then this, what happens is when I create a new policeman, this function is called, and because of the new operator, the this keyword points to an empty object. And then I run person and give that empty object to person, and since I'm using .call, the this keyword will be the same object as the this keyword here. Let's go ahead and attach the debugger to actually watch this happen. I've made a change so that I'm attaching the debugger to app2.js, and I'll just run it. So it calls util in, and we already know how that works. And then we have the greet method attached to the prototype. I run the inherit, and now I run new policeman. So I'll step into that. Now I have an empty object, the this keyword, which is ready to have its properties and methods attached. But before I attach the badge number, I say person.call this. We'll step into that. And now it ran this function, and the .call said that this keyword should be the particular thing that was passed in. So I add now first name and last name. And if I go look at the object, there it is, first name, last name. Keeps going. And now this keyword points to an object that already has the first name and last name attached to it. And now we add badge number, the extra property that I wanted for a policeman object. So now officer, if I was to go look at it, officer contains badge number, first name, and last name. Without the .call, I didn't have the first name and last name because that function constructor was never actually run. Util.inherits just connected the prototypes. So now I have all the properties and methods, plus if I dig down into the prototype chain, officer proto, now that will be the prototype coming from the policeman function constructor, so I need to go one level deeper down the prototype chain, another .proto. What is the prototype of this object is this object, and that has the greet function on it. So this object is the prototype of officer. So I have access to the greet method down the prototype chain, and I made sure that all the properties and methods added within the function constructor directly onto the new object are also there. So that's the basic idea. With .call, I make sure that the object has everything, not just what's down the prototype chain, but what's supposed to be directly on each new object. And now, since it has everything that it needs, I can call greet. And it says, hello, John Doe. So the object created from new policeman had all the properties and methods on it that it should have from both function constructors, and thanks to util.inherits, had access down the prototype chain to greet. All right, so this is a pattern that you see a lot if you're looking at Node.js code, including Node.js source code. However, ES6 adds another way to create objects, and we'll look at that now.